Hey everyone, so welcome to this video, and in this video we'll see the code of BFS algorithm, right? Also, in the previous video we have discussed about BFS algorithm and I've shown you how you can run the BFS traversal on graphs. So in this video also, let's discuss how to run BFS traversal on this graph, and after that we'll see the code, okay? So what I'll do, I'll push the root node, that is node number 0, to the BFS function, right? And mark this node as visited and push this node inside this queue. Now the next step is to run the while loop. So the condition of while loop is satisfied because queue is not empty. Okay. Now we are inside this while loop. The first step that we need to do is we need to get this element from the queue and store that element in some variable. Okay. So let's say this is a variable temp and we'll store 0 in this variable, right? After that we need to print temp, so I'm printing it here, and after printing temp we just need to pop out the front element from the queue. Okay, so it is popped out, and then we just need to visit the adjacent nodes of this element. Okay, so 0 is connected with 1 and 6 and both these nodes are unvisited, so we'll go to 1 and mark this node as visited and push this node inside this queue, right? Again we'll go to node number 6 and mark this node as visited and push 6 inside this queue, right? Now again we are at starting point of while loop, okay, and then we need to pop out the front element from the queue, so we'll store 1 inside this temp variable, then we'll print the temp variable and pop out 1 from the queue, right? And again for loop we just need to visit the adjacent nodes of 1, that is 0 and 2, but 0 is already visited, so we'll go to node number 2, okay, and mark this node as visited and push this node inside this queue, right? Again we are at starting point of while loop, okay, and then we need to pop out the front element from the queue. So here the front element is 6, so we'll print 6 here and pop out 6 from the queue, okay, and then we just need to visit the adjacent nodes of 6, that is 0, 2 and 7, but 0 and 2 are already visited, so we'll go to node number 7, okay, and mark this node as visited and push this node inside this queue, right? Now for loop is completed and we are back to the starting point of while loop, right? So again we just need to pop out the front element from the queue, so here it is 2, so we'll store 2 in this variable and print 2 here, and after printing we will pop out 2 from the queue, okay, and then we just need to visit the adjacent nodes of queue, that is 1, 6 and 3, but 1 and 6 are already visited, so we'll go to node number 3 and mark this node as visited and push this node inside this queue, right? So it is completed and we are back to the starting point of while loop, and now the front element is 7, so we'll store 7 inside this variable and print this variable, okay. After printing we will visit the adjacent nodes of 7, so here in this case it is 6, but 6 is already visited, right? So now we are back to starting point of while loop, okay, and it is popped out, and now the front element is 3, correct, so we'll store 3 inside this temp variable and then we'll print 3 here, and after printing 3 we'll pop out 3 from the queue, okay, and visit the adjacent nodes of queue, 3, so in this case it is 2 and 4, but 2 is already visited, so we'll go to node number 4 and mark this node as visited, also push this node inside this queue, right? So for loop is completed and we are again back to the starting point of while loop, right? So now in this case the front element is 4, so we'll store 4 inside this temp variable and print this variable here, and after printing that variable we will pop out 4 from the queue and visit the adjacent nodes of 4, that is 3 and 5, but 3 is already visited, so we'll go to node number 5, correct, and mark this node as visited and push this node inside this queue, right? Now for loop is completed and we are again back to while loop, right? So now the front element is 5. Okay, so we'll store 5 inside this variable and print this variable. So I'm writing it here, and after printing we will pop out 5 from the queue, right? And after that the for loop starts and we just need to visit the adjacent nodes of 5. So here in this case it is only 4, so but 4 is already visited, right? So now we are back to the while loop and the condition is false because queue is empty, there is no elements in the queue. So we are now come out of this while loop, okay, and this is the result, this is the BFS output, okay. Now let's see the code. So this is the code for basic graph, and here I'll create a function that is BFS and I'll pass root node inside this function. Okay, now we just need to create a queue, right? And after that we'll push the root node inside this queue and mark the root node as visited. Okay, now after doing this we just need to create a while loop, and the condition here is queue is not empty. Okay, now the first thing that we need to do is we need to store the front element from the queue inside a temp variable. Okay, so I'll make a variable here and I'll use front function for getting the front element, queue.front, and after that we just need to print out temp. Okay, and then we will pop out the front element from the queue. Now the for loop for auto it g of temp, and we will check whether the node is visited or not. Okay, if it is not visited we will mark the node as visited, right, and push that node inside the queue. So yeah, correct, and it is completed. We just need to call BFS function here, right? Now let's run this. So let me compile this first. It is correct. Now let's build this graph here. Okay, so here we have 8 nodes and 8 edges, 1 2 3 4 5 6 7 8, right? The first edge is 0 1 0 1, then we have 0 6, then 1 2 6 2, then we have 2 3 2 3 4 5, sorry 3 4, then 4 5, and then we have 6 7, right? And this is output 0 1 6 2 7 3 4 5, 0 1 6 2 7 3 4 5. So this is how you code the BFS algorithm. Okay,